Okay, welcome back. Let's finish off these last few questions here where we're going to be using the tangent ratio. Once again, don't forget that the tangent of an angle, let's say theta, is always the opposite side length divided by the adjacent side length. Now this of course is only for right triangles. So let's take a look at this triangle here in question A, where I have a marked 90-degree angle, so this side directly across it must be the hypotenuse. I have that this angle here is 38 degrees. This unknown x is of course the opposite side, and this 3.7 centimeters would be the adjacent side. So my tangent ratio would be the tangent of 38 degrees is going to be x over 3.7. Now, in order to solve for x, we're going to cross multiply. This is over 1, so x is simply 3.7 tangent of 38 degrees. Notice how I've written that, where I have the constant 3.7 in front of the trigonometric function tangent. So simply type this in on your calculator, 3.7 tan 38, make sure you're still in degree mode, 2.9 centimeters. So 2.9 centimeters. Your calculator display, of course, was 2.89075618. This is an approximate value, and this right here is an exact value. Depending on the tests you may be writing in the future, and even in grade 11, your teacher might say you're not allowed to use a calculator because you would be expected to just leave your answers 3.7 tangent of 38. And this, of course, is an approximate value of 2.9, valid to one decimal place. If this was two decimal places, it would be 2.89. Let's take a look at the second problem here. Again, a right angle. This side directly across the right angle is my hypotenuse. Here I have a marked angle of 57 degrees. So this is my opposite side. It is opposite the 57 degrees. And this side y is the adjacent side. So we'll set this up the same way. The tangent of 57 degrees is opposite, or 14 millimeters, divided by the adjacent, which is y in this case. So again, cross multiply and we get y tangent of 57 degrees this time is equal to 14. Now this tangent of 57, this is just a number. So we could divide both sides by tangent of 57 degrees. And this side by tangent of 57 degrees to get y is equal to 14 over the tangent of 57. And when you put that in on your calculator, you will get 9.1 millimeters. Again, just type in on your calculator 14 divided by tan 57 and press equals. This last one here, when you're trying to find an angle, the angle is unknown. This is problematic in that we're going to have to use the inverse tangent function, or tan inverse. So we need to get our calculator ready for that. But let's see what we can do with setting up the problem. This is clearly the hypotenuse. It is directly across the 90-degree angle. This is the angle I'm looking for. So this 8 is the opposite side, and this 13 is the adjacent, or the side beside the 13. Always mark the hypotenuse first, then mark the side opposite, and then the side that's left is the adjacent. So the tangent of theta is going to be opposite divided by adjacent, or 8 divided by 13. So theta is going to be the tan inverse of 8 over 13. Again, make sure your notation is the exact same as mine. There are no variations on how you do this. This is not an opportunity for you to be creative with your solution. If you do it any other way, it is wrong. So theta is the tan inverse of 8 over 13, and make sure you use the second button. So you're going to need to use the second key and then tan in order to find that angle. So if you do that, you will get 32 degrees. That is to the nearest degree. So that's the nearest degree. Okay. Usually we do sides to the 1 decimal place and angles to the nearest degree. That's normally what we do. Last and not least here, I have some our Greek letters in our Greek alphabet, and I'm going to point out the ones that are used the most often. Alpha, beta, where on earth is theta? Theta, 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 where are you? Theta, and possibly lambda. And I like to use mu in my senior courses when I teach vectors. Pi, you should recognize pi. Do not use pi as a variable. It is a constant, but they're all there. So alpha, beta, gamma, delta, epsilon, zeta, eta, or zeta, eta, theta, iota, kappa, lambda, mu, and so on. And like I had said, one year I was pretty cruel. I told my students that they needed to know these. I didn't start it. They asked, "Sir, do we need to know these?" And my response was, "Yes, it's going to be on your quiz. Why don't we do our quiz tomorrow just so that we get it over and done with?" And they decided that I was going to be serious that day. If you are pretty good at counting, you'll notice that there's only 24 of them. Same group of students, I told them to go home and learn how to write their name in Greek letters. Of course, this is A, B, C, and so on. And it didn't dawn on any of them that there are only 24 letters in the Greek alphabet, and the alphabet we have is 26. So it was an interesting next day. They were not very excited to see me when I told them I was kidding, by the way. And that is the end of that lesson. Just maybe one more thing to sort of refresh. If you have a right triangle, let's make it a bus. And this is the angle I'm interested in. This is always the hypotenuse. This is directly opposite. This is the adjacent. If instead my bus is rotated slightly and maybe doesn't look very appealing here, we'll make that S and that B. And let's say I'm interested in this angle over here. This is my opposite. This is still my hypotenuse because it's directly across the 90 degrees. And this is my adjacent. And that's it for video number 2.